Section 6.2. Section 6.2 is how to convert X to Z. Now, most of the real problems are not dealing with Z value, they're dealing with X. And let's look at these examples that you have here. It said height of the men's are normally distributed with a mean of 68.6 and a standard deviation of 2.8. See, when we discuss table A2 and Z value, we mentioned that is for a standard curve. Okay? And a standard curve has a horizontal line that is Z value. But in the real problems, we are not dealing with Z. Now, I'll show you here. For instance, in these pictures, you see that, as in this example, it showed that the height of the women, this is just an example for one particular group. Mean of height is given and a standard deviation is given. There is another group of men that their mean and heights are different. So these are not a standard curve anymore. These are the type of bell-shaped curve that have different mean and standard deviation. And based on that, you have a different shape. So since there are so many X values and standard deviation values, we need to do the conversion because the only table we have right now is table A2, which is designed based on Z. So we have to do a conversion from X to Z in order to use the tables. And in order to do that, we're using this formula to do the conversion, which is Z is X minus mean divided by standard deviations. So Z is X is the value given in the problems, mean in the standard deviation of mean is mean of populations, and sigma is the standard deviation of populations. So in this example here, height of the men's are normally distributed. Mean of population is given is 68.6, and a standard deviation also. So 68.6 is mean of population, and the standard deviation of population is 2.8. And X value, find the percentage of the men who have taller than shower head at 72 inch. Okay, so this 72 inch is the X value, is a number that varies from problem to problems. Now, what's the main difference between the standard curve and normal curve? A standard curve, the horizontal axis, it had the Z and minus Z, and remember the middle ones was always 0, and when you go to the right, the numbers are increasing 1, 2, 3, and to the left -1, -2, -3. But the X value is always positive because we are talking about, like in this case, we are talking about people. So we have to use a positive numbers for that. So in that case, we want to find probability of X greater than 72. Since our table is based on Z, we have to do the conversion from X to Z value. So this is a formula to use to do the conversions. Both formula are the same, whether you're in the problem you're dealing with population or samples. So if you're dealing with populations like the one here, then these are the symbol to use. And when we are dealing with the sample problems, then these are the symbol to use. But either one, you always have population or samples, but the formula again it remains the same. So in these problems, we already have X mean and a standard deviation. We put everything in the formula that give us the Z. So now, instead of saying find probability of x greater than 72. Now we say find probability of z greater than 1.21 because 1.21 or the z value is comparable to the x that you have. So now we need to find probability of z greater than 1.21, which is this shaded area. That you could find it through the tables. You remember the table always give you the area to the left, and then you have to subtract from 1. Or I think it's easier if you just use the calculator. If you want to use the calculator and you have the value of z1 and z2, then the calculator, the z1 is 1.21, and then you have to give a big number to the calculator, like +5. Or what you could do, if you don't want to do any conversions, if you don't want to convert x to z, you could go and directly use this formula in the calculator, okay? X is greater than 72. So x is always a start from 0, go all the way to infinity here. So you just throw a very large number, you know, it doesn't matter what number it is. So one end is 72 and one end is what? Let's just throw that number, 1000. And then you put the standard deviation of population and mean of population. That would give you the answers. That would give you this area. So this is a good formula to use. See, like in this example here, which you have it in the textbook, the US Air Force requires that pilots have height between 64 and 77. And height of the women are normally distributed with a mean of 63.7, a standard deviation of 2.9. And find the percentage of women who meet the height requirement. So for this problem, this is the solution you have on the textbook. If you really want to do the conversion stuff, you have to do 2 conversion. Why? Because you're talking about 2 heights, 77 and 64. Or on this page, I show you both methods. Basically, what we're looking for in this problem is x, find the probability of x is between 77 inch and 64 inch. So for that, we have to convert, this is like probability of between x1 and x2. So we have to convert these 2 numbers to z first, and then do the problems. Or from the beginning, if you really want to find the area and you have the value of x1 and x2, you could take all the numbers and put it here, and in one line you have the answers. Because when you use a calculator requires boundary numbers. x1, x2, mean and standard deviation. You have all in the problems, and you put it to find your text. This problem is, we are basically asking you to go from the area and to find the x value. Means area is given, probability is given, all right? I put that here, let me see. I did some calculation here for you to understand that if you have the area, or if you have a probability, how do you find the x value, okay? So when you have the area, you could either go through the tables and find the area that is close to 0.95 or it is 0.95 and read your z value. When you find your z value, then in this formula, you have the z, you have mean and standard deviation, you could find the x. Okay, so again, if you want to find your z value, you find the second inverse normal, because you want to do it backward. You have the area, you want to find the z value. When you find the z value, then in these problems, when you cross multiply, you could find the x, and they're looking for x. What they're saying in the problem is, if the area or if the probability is 0.95, what is the x value? And these problems are very similar to that one, so I guess you could read these problems yourself. And I made two examples here, these two examples for number 7. They are saying that find the area, means number 7, we give you the x values. We give you x1 and x2, and we ask you to find the area. And on number 9, you have the area, and we ask you to find the x. So for the first one, if you have two boundary or two x value, and we ask you to find the area, you could go directly and use your calculator. And doing that, you find the area. Or again, if you have the area and you want to find your x, you could just put it into this formula. You put the area, mean, and a standard deviation. See, before, when we use the inverse norm, there was a formula for inverse norm. All we need to do is put the area, and the calculator will give you the z, right? Why? Because in that case, that was a standard curve, and a standard curve, calculator understand that mean is standard deviation is 1 and mean is 0. So all you need is just the area. But here, since you are not dealing with the standard curve, we gotta tell calculator that, hey, the mean is not 0 anymore, mean is 100, the standard deviation is 15, and this is the area. And then calculator will do it for you. And I have this on this page for you. This is in case you want to find the area. This is in case you have the area, you want to find your x.